Mm-hmm. Yep. Okay, no worries. Hello, everybody. Welcome back to another live stream from the Scalar Learning channel. I am just checking, making sure the audio is good to go. And I believe it is. Here we go. Ladies and gentlemen, it is now November. And we've got the, sorry, let me mute this. We've got the SAT coming up this Saturday, which is crazy and exciting for those of you who are taking it. Maybe for the first time, maybe for the second time, maybe for the third time, etc. But it's exciting, and it's an opportunity to do your best and show what you can do. And as always, I am here to guide you along and give you an opportunity to review with me. So if you're new to the channel, welcome. And what I've been doing lately that I've been really getting into, and this is actually the 20th video of these series, which is really cool, but this is the mini test series. I love these mini tests. I have said in the past that these Khan Academy practice problems, sometimes there's a divergence between them and the real SAT stuff and that the College Board provides, especially when you get to level 3 and 4. But these mini tests, I feel like, do a pretty good job. Now, of course, I'll tell you as we go along questions that I'm like, this seems like a stretch or whatnot. But in general, I'd say it's pretty legit in terms of the content and the difficulty level provided. Okay, so the way it works with these mini tests is I'm taking it for the first time in real time, so I'd never seen these questions before, so I'm just going with the flow, and you're gonna see me problem solve live on camera. And that's part of the fun. That's part of the excitement. So without further ado, we're going to get going. What's up, Mustafa? Welcome from Egypt. Awesome, awesome. Okay, here we go. And we got the calculator up on the left. If we need it, here we go. We're going to start in, because the calculator is allowed. 3, 2, 1. Let's do it. An ancient China. You know what? Let me do I should probably zoom in. I think I can zoom in a touch here. Oh, no, it's too much. Okay, an ancient Chinese candle clock tells the amount of time that has passed by the amount of wax that has been melted off the candle. Each candle is divided into 12 sections marked 1 inch apart. Got it. So it's like a foot, right? 3 like this. It takes 4 hours for each candle to completely melt. So all 12 takes 4 hours to completely melt, after which a new candle is lit. If 2 candles have completely melted and 1 candle is melted 4 inches, how many minutes have passed? So check it out. We've got, 2 candles. So each candle takes 4 hours. So we know we got 4 hours and 4 hours. So we know we're at 8 hours. By the way, we still have to convert this. So, just give me a second here. Then we got 4 inches. So then that's 4 out of 12, or 1/3 of that last hour, right? So 1/3 of 4 over 1, which means 4/3. So check it out. We got 8 hours, and that's 9 hours, 9 1/3 hours. But now we need to convert it to minutes. We could use a calculator, but maybe I'll just do it without it, just for fun. So I'm going to turn it into a mixed number, or improper fraction. 9 times 3 is 27, 28 out of 3, and then we have to multiply it by 60. Boom. Simplify. That turns into 20, and that's like 2 times 20 is 556. With a 0 is 560. C is the winner. That's an interesting question. And done. Next, a scientist wants to compare, what's up, Mac Polo? A scientist wants to compare the behavior of dolphins in part of the Gulf of Mexico contained by an oil spill to the behavior of dolphins in a part of Mexico not affected. Which of the following is the best description of the research designed for this study? Not a sample survey, because you can't sample, dolphins. This is an observational study. I'll get back to why in a second. It's not a controlled experiment, because a controlled experiment would be like, okay, I'm going to take this part and I'm going to dump oil here, and this part I'm not, and we're going to see the reaction. This is kind of what already happened. So I wouldn't say that, but I would say an observational study. Oh, I don't like it when they say none of the above. It always makes me second guess myself. But essentially, that's what they're doing. They're doing an observational study, and they're seeing the differences. So I would say that's the winner. Okay. The graph at the left in the TD plane shows a relationship between T, which is, what is T? Days after January 1st, and D, distance in the Earth, between the Earth and the Sun distance, minus mean distance, Sun at time T subtracted by the mean distance between the Earth and the Sun. Okay, so it's the current distance minus the mean. So you see there's a mean value, and it's like, okay, here it's below the mean, here it's above the mean, so there's some oscillation, I guess, in this thing. It almost looks like a sine wave. What is the approximate difference between the maximum and the minimum distances of the Earth from the Sun in thousands of kilometers? Well, here's the thing. There, oh, yeah. It doesn't matter. Okay, I was going to say, because we don't actually have the values, but it doesn't matter because we can just kind of use this value and this value. Because here's the thing. It doesn't matter what the distance is. Like if the mean was 1,000, this would be 1,025, and then this would be 975. But it doesn't matter. We just basically take the difference of 25 minus negative 25, which is basically 25 plus 25, which is 50 for the win. I believe that's correct. And done. Next. Haven't needed the calculator that yet. The property taxes in a town decrease as the distance from the hall increases. For every 5 miles from the town hall, property taxes decrease by 0.2 percentage points. Okay, so for every 5 miles, okay, so which of the following equations can be used to determine how far north or south the town hall a house is whose property taxes are 0.76 percentage points less than the taxes at town hall? Okay, let me think about this for a second. Well, I'm going to solve this first of all. So your 0.2, it decreases by 0.2, and this is 0.76 percentage points. So let's see here. So 0.76 divided by 0.2. So that means you're 3.8, and then that's for every 5, right? So I have to multiply this by 5, and that would give me, you're 19 miles away. So at least now we know what the value is. We're 19 miles away. And by the way, it could be plus or minus 19, right? Or no, actually, it has to be just straight up 19 miles away. Oh, yeah, 19 miles north or south. That's what I mean. So we're 19 miles away, and what would give us 19? Not A, it would be B. Because if you do 0.76, look, check it out. 0.76 divided by 0.04 is 19. This would give me 0.19. This would give me 0.19. So this is the only one that makes sense based on what we know the answer has to be. Oh, that's what they got the 0.04. I was like, where's the 0.04 coming from? They did 0.2 divided by 5. So that's for every mile is 0.04. Anyways, so that makes sense. So every 0.04 per mile, boom, and we're trying to get to 76. That's the winner. B, boom, done. Number 5. A rectangle said to have a golden ratio if the ratio of its length to width is, hold on, let me see the time. How much time do I have? All right, 10 minutes. A rectangle said to have a golden ratio if the ratio of its length to width is equal to approximately 1.6. So it's like 1.6 to 1. So which of the following graphs represents the relationship between length L and width in a golden rectangle? So we need a slope of 1.6 basically, because this is length, this is width. So up 1.6 over 1. Up, this looks pretty good. A looks pretty good. Let me look at the rest of them. I'll select it, but up 1 over 1.6, no. Length to width is approximately 1. Yeah, because I wrote it out the right way. That makes 0 sense. And up 1.6 is 0. No, this doesn't make sense. This isn't the right slope. That's like up 1. No, it's wrong. It is A linear relationship. Boom, done. The system of equations represented by the graph at left is this. Which of the following ordered pairs is a solution to the system? Got it. So there's only 2 soluciones. It's where they intersect. Boom, boom. I'm guessing it's this one because this is like right on a coordinate, which is -2, 4. And C is the winner. So the other one here would be like about 2,5, but I'm not saying 2,5 because it looks approximate. Okay, we should probably double check though. Let's plug them in. So -2,4 feels good. So if I plug -2 in here, I get 4 times 3 is 12 minus 8 is 4. And that's correct, -2,4. Now double check here. -2 in here, that'd be -3. Squared is 9. 9 times -1/9 is -1. Plus 5 is also 4. Boom, verified. In a particular county, a census of the population showed that 84% of the households lived in the same residence as they had the previous year. Got it. The census had a margin of error of 1.5% at the 90%. So I'm going to ignore the confidence level for now. So that means it could be 85.5 down because I'm adding it and then I'm subtracting it, 82.5. So it's in here somewhere. If the county has 50,000 households, which of the following best estimates the number of households that lived in the same residence as they had the previous year at a 90? Okay, so it's just the range, and we just take these percentage values that I got from adding and subtracting the margin of error times that 50,000. So first we do 0.825. That's 82.5% of 50,000, aka multiply 50,000. So the lower bound is 41,250. We already know it's probably C, but I'm going to double check anyways just for fun. So we multiply the top, which is 0.855. 0.855 times 50,000 equals 42750. Boom, done. Next. 4 minus 3y equals 6y plus 4 minus 9y. Which of the following best describes the solution set to the equation above? Okay. Cancel, cancel. Add 9y to this side, and we get 6y equals 6y. All real numbers. Because when you have the same thing on both sides of the equation, it has, basically it actually is all real numbers, but it has infinitely many solutions. That makes no sense. That makes no sense, and that makes no sense. And we can just double check if you want. Well, you don't really need to, but you could try like 1, and it works because you get 4 minus 3 is 1. 6 minus 9 is negative 3 plus 4 is 1. And then try 2. You get negative 2 here. 12 minus 18 is negative 6 plus 4 is negative 2. There's 2 solutions right there. So it's pretty good. Infinitely many solutions. 2 questions left. 76 is this. What is the greatest value of x to the solution above? All right. I am going to square both sides. So I get 49x squared equals 169x, right? Square that and square that. Then I'm going to subtract both sides by 169x equals 0. Then I'm going to factor out x, and I get 49x minus 169 equals 0. Obviously, 0 is a solution, but that's not the greatest value of the solution. The other one is when this goes to 0, aka I'm going to set this equal to 0. Oh, actually, 0 could be the greatest solution, but we'll see it won't be. Then 49x equals 169. Oops. Because I added 169 to both sides. Divide by 49. Divide by 49. You see they left it nicely in the improper fraction, 169 over 49. Nothing fancy in my methods. Nothing crazy. Nothing tricks and this and that. It's just, I'm just doing the math. And look, I'm still doing great time-wise, right? So, and I'm explaining everything within the time. So you see, just know the math. A marine aquarium has a small tank and a large tank. Each containing only red and blue fish. In each tank, the ratio of red fish to blue fish is 3 to 4. So 3x, 4x. And I'll say this is 3y, 4y, because they're different values, I assume. The ratio of fish in the large tank, to fish in the small tank is 46 to 5. So I would say, if I added these together, I would say 7y. Hold on a second. Let me write this out. Large to small. So I'd say 7y to 7x equals 46 to 5. Cancel the 7s. All right, I don't know if that really helps, but that means 46x equals 5y. Okay, what is the ratio of blue fish in the small tank to red fish? Okay, blue fish in the small tank to red fish in the large tank. 4x to 3y. Oh, I see. And then now we can plug and chug because we can substitute here with this equivalency. And we can go either way. So 36. Okay, 3 minutes left. I got to hustle. So I could say that y equals 46 over 5. Y equals 46 over 5x. So I plug it in there. 3 times 46. Hold on. 3 times 46 is 138. So it's 138 over 5. So it's 4 to... And I can get rid of the x's because now they'll both have x's. 4 times 138 over 5. I can, but you know, x's are there, but we don't care now. And then we don't want a fraction. Uh-oh. Oh, yeah, I get it. So then we multiply both by 5. So then we get 20 to 138, basically. And then they just simplified that. So we can divide both by 2, and we get a 10 to 69. and that's B. 10 to 69. What is the ratio of bluefish in the small tank? And it's got to be the small one first. It can't be the big one first because obviously it's small tank. Well, not obviously, but probably it's going to be the smaller one first. So I feel like I've seen this problem before because it's like so weird and it sounds familiar, but I can't remember. Okay, we got 2 minutes left. So normally, obviously, you would use your time to double, triple check, quadruple check all your answers. But we're just going to go for it and see how we do. Hey, 100%. Okay. Let me see some of these comments here. I'm not understanding this question, MacPole. I'm not sure which one you're talking about, but let's see. It's my last chance. What I'm doing is covering the concepts from Khan Academy. Yeah, and on Gunbeer, by the way, you can check out our video course 2, by the way, guys. We got 3 full practice tests and 3 full sets of video explanations. The link is in the description below. It's a monthly thing, too. You can sign up for a month and then cancel, and it's $30 per month. So you can definitely check that out as well if you're interested. A fresh new set of practice tests plus other resources as well, downloadable. It's just dope. So definitely check it out if you're interested. And let's see who. By the way, our Discord community you can join for free as well. It's just a bunch of awesome, really cool students that are willing to help each other and talk shop. So that's also there as well. It does check that once in a while if you're asking. Yeah, you can ask me a question. I gotta go pretty soon because I've got to start tutoring very soon today, and I got a lot of work to do. But I'm a freshman, so can you take it easier and explain a little more? So check it out. So these are meant to be a little bit speedier, a little bit faster if you're new to the channel. What I would recommend is go watch my critical concept videos. Those go much slower. Also in the video course, I go much slower and in more detail for each question that I'm reviewing. So you can definitely check that out if that's what you're interested in. Okay, super quickly, the last problem is going to take me a while to re-explain. I would encourage you, once this video goes up, you can re-watch my whole breakdown of how I kind of put everything out. But in general, we're talking about ratios. A lot of times they say 2 to 7 ratio. I say, okay, 2x and 7x. It's a really nice way to break it down. And then I was just kind of gathering up all those relative values, comparing them, etc. A little substitution in the mix. Okay, guys, thank you so much. I'll be back again tomorrow and the following day and the following day, so you guys get as many as possible of these live streams leading up to the test, and we'll do one more big video. All right, I wish you all the best of luck.